right, we're going to look at vector applications today. Vector applications deal with vectors, of course, but they're also going to deal with what's called the resultant force. Okay, if you can read, you can see that it says the sum of all the forces acting on an object is called a resultant force. Okie dokie. So, by that it means that every object has a vector that's acting upon it from different directions. So we have to take all those vectors into account when we're looking at the way an object is going to move, which is going to end up in the resultant force or the resultant vector. So let's take example 5 right here. An object moves at the origin is acted upon by two forces. A 300-pound force makes an angle of 35 with the positive x-axis. So I'm going to take this part right here. Notice the positive x-axis. That means we're going to be down here, all right, in quadrant 1, angle 35 degrees, and I have a 300-pound force right here, all right? There's my pretty picture. And then the other force that's acting upon it is 125 pounds that makes an angle of 85 with the positive x-axis. So here's my other one at the 85 degrees, and that's going to be a 125-pound force. What I'm going to look for, though, is when those two forces act together, what's going to happen? What's going to be my result? My result is going to be this guy right here, that's OR. Because I'm pushing from both sides, so I need to find where it's going to meet in the middle to find my resultant vector. Thanks, Jake. So now, we've got two vectors we're working with. We have got OP, which is a 300-pound force, and then we've got the OQ, which is the 125 force. So first we need to go ahead and find the vector of OP. So we know it has a 300-pound force, so that's its magnitude. So remember from yesterday, our A hat, our AI, and our BJ, we have to add those together, but remember, since we have the angle and we have magnitude, we're going to have to use our cosine formula. So remember this guy, the magnitude of cosine theta, and then we have the magnitude of sine theta. So we're going to use those formulas with our i's and our j's, and we're going to put those together. So for our A value is going to be cosine, and the magnitude is going to be 300. So we have 300 cosine. Our theta, our angle, is going to be 35. And that's going to be our I. Plus our B value is going to be 300 sine 35 J. I'm going to go ahead and I'm going to look at my vector OQ, and it's going to be the same concept again. But this time our angle is going to be 85, and our magnitude is 125 because that's the force acting upon it. So I've got 125 cosine 85 I plus 125 cosine 85 J. So now all I have to do is do the simple math and simplify. All right, so 300 cosine 35 gives us 245, let's say 0.75 I, and then 300 sine 35J gives us 172.07 J. I'm going to go ahead and grab the numbers for my vector OQ. 125 cosine 85 gives me 10.89 I, and then 125 sine of 85, oops, I just realized I wrote that wrong, is 124.52 J. This guy right here should not be cosine, he should be sine. My apologies for the error. So now we've got our OP and we've got our OQ. Since we want the resultant vector, what I need to do is I need to go ahead and add those together. So I'm going to take this guy right here and this guy right here, and I'm going to combine them. I'm going to go ahead and I'm going to copy this and put it on the next page so that we have some room to work. Let's see, so we've got this guy and this guy. Let's go to a new page. So I've got these two right here. And what I'm going to do is I'm going to add those together. Because what I'm really finding out is I want the vector OP plus vector OQ. So combine like terms, combine my i's, and then I'm going to go back and I'm going to combine my j's. So let's see, 245 point, if I can calculate it right, that'd be great. 245.75 plus 10.89 gives me 256.64 I. And then my j's added together are going to be 296.59j. So now we have our resultant vector, and we need to go see if it wants it in any particular format or if I've answered the question that it's being asked. So let's go back to our original problem. And the question wants to know, find the direction and magnitude of the resultant force. So now I need to find direction and I need to find magnitude. So I know that that is my new vector, so I need to find direction and magnitude now. All right, so to find magnitude, remember, magnitude equals a squared plus b squared, and find the root of that. So all I'm going to do is my magnitude of my resultant vector. And guys, your resultant vector is going to be the OR value. So this is the OR vector. So we've got the square root of 256.64 squared plus 296.59 squared, and then I'm going to root it, and that's going to give me my magnitude. So that's squared. I'm going to grab my handy dandy calculator, and we get magnitude of vector OR equals 392.22. There's our magnitude. Now we need to go ahead and find our direction angle. Remember, direction angle has to be between 0 and 360, so it has to be positive. Direction angle, remember, is the tan of theta equals b over a. So I have my a, I have my b, so I'm just going to plug that fun stuff in. So I know I'm finding an angle, so I have to do the inverse of tan. And then b is my 296.59. And I'm going to divide that by my 256.64. Make sure your calculator again is in degrees, because if not, it's going to spit out the wrong answer and you're going to be incorrect. Remember, we're dealing with degrees, so it has to be in degrees. And we get tan theta is equal to 49.13 degrees. So since our vector starts off positive, it's in the first quadrant, and my angle is positive, and it's between 0 and 90, which is less than the previous vector, I know that I'm good. So here is my direction angle, and there is my resultant vector. So we have finished the problem. We are done. So going back to original equation, this guy right here, my OR vector, that's at an angle of 49.13 degrees with a vector or magnitude of 392.22. Okie dokie. That's the end of that one. Get ready for the next one. If you lose